Right, part 2 of trig is remembering how to solve your trig functions. So if we've got something like this, find the zeros of f of x equals that. So what we're trying to do is go right, 0 equals sine x plus a half, put the half on the other side, so it's minus a half equals sine x. Now we could just go, well, I'm trying to get rid of sine, so why can't I just inverse sine and get my answer using my calculator? That is because if we look at the graph, there isn't going to be just one solution. This is the line y equals minus a half, and you can see that we have not just one, but two solutions here where that's going to cut the graph. And these are the two answers that we want to try and find algebraically. It's a reasonably simple process. The first thing you have to do is remember, what is your working angle? So that's saying sine of what equals a half. Now hopefully you can remember either from your unit circle or your table that we have that the working angle for sine of being a half is pi on 6. Remember the table. I also have a little trick where I have this triangle that I remember. The only thing I have to remember is that if I've got 30 degrees, which I know is pi on 6, plus 9, so 90 take 30, I'm left with 60 degrees here. I know that sine of 30 is a half, so opposite over hypotenuse. Using Pythagoras, I get this little root 3 here. 2 squared take 1 squared, gives me root 3. And now I can get sine, cos and tan of 30 and 60 from here. So cos of 30, or pi on 3, is root 3 on 2. Sine of 60 is opposite over hypotenuse, so again root 3 on 2. Tan of 60 is opposite over adjacent, and I can get all those values. Anyway, that's just a trick I use. You can take it or leave it. You could just use your working angle diagram if you so desire. So this one here, so you're looking at when is sine negative a half. So here's your sine value here. It's down at negative a half. So we've got here and here. I like to use the table because I don't actually remember or have that. So I've got this table on my triangle. And so what I can do here, so okay, I know my working angle is pi on 6. In which quadrant is sine negative? So it's negative here and here. So it's down at pi on 6. Pi on 6. Now if that's a whole pi, this is 2 pi. What's a whole pi? Plus another 1/6 of a pi. So 1 plus 1/6 is 7 pi. So that's 7 pi on 6. And then 2 pi take 1/6. So 2 wholes take 1/6 would be 11 pi on 6. And so those are my two values. And if we go and have a look at our diagram here, that's what we got here, 11 pi on 6, 7 pi on 6. And if we then confirm that with our graph, where they intersect, 7 pi on 6, oops, stay there. And then here was 11 pi on 6, which is what we got. So that's how we would do it algebraically. Let's do a slightly harder one now. So the previous question, the period wasn't an issue, it was the same, it was just 2 pi. In this one, we can see straight away that the period is going to be different, and so I will be expecting more answers because this is saying the graph is going to be doubled. It's going to be 2 of those graphs in the same period, so I should be expecting more solutions. So we carry on, we go, yep, we're finding the zeros, so we're making that equal to 0, so 2 cos 2x. Take 1, the 1's going to go on the other side. To get rid of a times 2, I will divide by 2, so that becomes a half equals cos 2x. Again, for me, I'm looking at this and I go, well, what would be my working angle? Cos of what equals a half? So you can go back and look up your table, you can look up your unit circle. Something that we need to know by now. And again, my thoughts are, well, I know sine of 30 is a half. That means cos of 60 has to be a half. So my working angle is pi on 3. If you're not comfortable with that, as I said, go back, look over here. So we're saying cos of a half, that's pi on 3. So that's how we can get our working angle pretty quickly. It's then a matter of remembering what quadrants we're in. So remember that if this is our cosine, we're saying cos is going to be positive. So cos will be positive here and here. Something we forgot to talk about, I guess, a little bit earlier on. That was something that we did need to remember. So if we're talking about, this is our cosine, this is our sine, in this quadrant we say that everything is positive. Cos is positive, sine is positive, and tan is sine over cos, so that's there. In this quadrant we say that's S because only sine is positive. So positive upstairs, cos is negative, and so remember tan, sine over cos, positive and a negative means it's tan is a negative. In this quadrant, sine is negative and cosine is negative, therefore tan is the only one that's positive. And last but not least, in that section, cosine is the one that's positive. So I tend to just remember that if this is my cosine axis and this is my sine, I should be able to work it out because of my knowledge of the x and y axes. Anyway, you do what works for you. So here we go, it's cosine is positive here, so we've got pi on 3 here and pi on 3 there. We take it from, so 0 plus pi on 3, therefore 2x will be pi on 3. And then we're coming down, so this is 2 pi, so that's 2 wholes, take 1/3. So I go to 6, 2 3s are 6, so that's going to be 5 pi on 6. I'm sorry, don't know where that 6 came from. It's not 5 pi on 6, it's 5 pi on 3. Plus k lots of 2 pi because we're doing laps, and if I do another circle around, we know the period is 2 pi, that's why I have to go around 2 pi times. I can keep going, keep going. Now, I don't want 2x, I just want x. To get rid of that times 2, I'm going to divide everything through by 2. So I get pi over 6, because 1/3 divided by 2 is 1/6. That will be 5 pi on 6. And this time now, the period is now going to be only pi, because 2 divided by 2 cancels out, so it's k lots of pi. And I can now say, well, between 0 and 2 pi, I'm going to have pi on 6, 5 pi on 6, and then I'm going to add a whole pi to this. So 1/6 plus another whole will be 7 pi on 6, plus a whole here, that will be 11 pi on 6. If you're not happy with the fractions, grab your calculator and work out what's 5 on 6 plus 1 whole, and that will give you the 11 on 6, and just stick a pi in there. So those are now my zeros for that solution. You can graph it, you can check it. Okay, another one here. This has now got a horizontal translation, and because there's no number in front of the x, we know that it's not going to affect the period. So here we go, get the zeros. So 0 equals 2 sine x minus pi on 4. Take root 3, I'm going to put the root 3 over the other side, get rid of the times 2, so we get root 3 on 2 equals sine x take pi on 4. So again, we need to find our working angle. So sine of what is root 3 on 2? Let's go back to our table if we've forgotten. Sine of what is root 3 on 2? So sine root 3 on 2, that means I've got a working angle of pi on 3. So my working angle is pi on 3. I'm looking now at this being positive, so that puts me in what quadrant? So sine is my y-axis, it's positive up here and up here. So we're going to go up here pi on 3, across here pi on 3. Therefore, x, so that thing there, x minus pi on 4 equals pi on 3, and then this again, you can do the fractions, a whole take 1/3 because you're going back the other way, so a whole take 1/3 is 2/3, so that's going to be 2 pi on 3 plus k lots of 2 pi. I forgot to do that in the very first question. You've always got to put that on. So I don't want x take pi on 4, I want just x. So this becomes pi on 3. To get rid of a take pi on 4, I'm going to plus pi on 4. And 2 pi on 3 plus pi on 4. Again, plus k 2 pi. I don't add the plus pi on 4 there. The only thing that affects the period is the number in front of x, and because it's 1, it's not affected. It might be the end of the day for you. You can actually use your calculator to work this out if you want. Ignore the pi's and go, what's 1/3 plus 1/4? I'm doing that on my calculator as we speak, and I get 7/12. So that will be 7 pi over 12. Do the same for 2/3 plus 1/4, and I get 11 pi over 12. Plus k lots of 2 pi. Now, if we had a boundary, so if we had a domain of 0, x, 2 pi, we would check if I take 2 pi, I'm going to get less than 0 from each of these. If I add 2 pi, I'm going to get more than 0. If this was a larger value, so 4, I would then add 2 to this, add 2 to this, so I didn't go beyond my value. We can do more of this in class, but that's the gist for solving trig functions. Hope it helps.